Yes, very good afternoon, children. We were talking about invariant in the earlier class. I would like to explain in this video about exercise example problem in your exercise 18.8.7, a sparrow problem. The problem is explained in your textbook like this way over here, saying that you have six sparrows and six trees. You have six sparrows and six trees. Okay. Then they say that two constraints are there. One say the sparrow should travel equal distance from one tree to the other tree in equal distance. That's one thing. Second condition is if one sparrow is traveling from left to right, the other sparrow should travel the same distance from right to left in the opposite direction. So these are the two concepts. When such things are happening, they are asking you a question if whether all the six sparrows can sit on one tree. This is the question. I'll repeat the question. There are six sparrows and six trees spaced equally. Trees are spaced equally and six sparrows. And then if a sparrow flies from one tree to another, then at the same time, another sparrow flies from the tree in the same distance in the opposite direction. Okay? And they are asking you, is it possible for all the sparrows to gather on one tree? I'll explain this problem now. Okay? So now you have your one, two, three, four, five, six trees, and the number for each sparrow is numbered by your this is sparrow one, sparrow three, sparrow two, sparrow three, sorry, sparrow two. Like that, you have this. Very simple. I don't want to go with the textbook explanation. I'll come back to the textbook explanation as a lay person. What they are saying from one tree to the other, the sparrow should travel like this. Clear? At one stage, they're asking in the opposite direction. They want to travel like this way. At one stage, when you're doing it like this way, they want to find out whether all the six can sit on one tree, maintaining the condition, two conditions. The sparrows, one sparrow from one direction flies to the other direction, opposite direction, the same distance, the other sparrow should follow. This is a constraint. Okay. Now remember this. So clear. Now using this constraint, clear, we'll see how this works out. Okay. Yes, sir. We'll see. Clear. First thing is from the first tree, when a sparrow is going to go to the second tree from here to here, it comes over here. Okay. So how many sparrows will be on my second tree? Two sparrows. Same way when it's coming over here, six to the opposite direction, simultaneously there is going to be clear. Now from here to here, from here to here, okay, how many sparrows are going to be over here? Two sparrows is going to fly over here plus one sparrow in my third place. So it is going to be three sparrows over here and three sparrows over here. Now, see, so now what happens over here is either for all of them to sit on one tree, if I say you can say Miss 3 plus 3 6, இங்கே உட்காரலாமே அப்படின்னு சொல்லலாம். ஆனா இங்க என்ன கண்டிஷன் ஃபெயில் ஆகுதுன்னா simultaneously three sparrows should fly in the opposite direction. That is not possible. 3 plus 3 6னா ஒரு டைரக்ஷன்ல போயிட்டு இந்த ட்ரீல வந்துட்டு சிக்ஸ் ட்ரீஸ் ஒரு ஸ்பேரோ ஆறு ஸ்பேரோ இந்த ட்ரீல உட்காந்து ஆனா நம்ம கண்டிஷன் என்ன சைமல்டேனியஸ்லி இந்த த்ரீ இங்க போயிடுச்சுன்னா அப்போ இங்க த்ரீ பேக் டு த சேம் பொசிஷன் விச் இஸ் நாட் பாசிபிள் because we don't say that simultaneously இந்த மூணு ஸ்பேரோ எங்க ஃப்ளை ஆகுதுன்னா இந்த மூணு ஸ்பேரோ ஆப்போசிட்ல ஃப்ளை ஆகணும் அதுதான் நம்மளோட கண்டிஷன் இப்ப நம்ம கண்டிஷன் வந்து மூணு ஸ்பேரோ ஏதோ ஒரு டைரக்ஷன்ல ஃப்ளை ஆகுது அப்படின்னு சொன்னா இந்த சிக்ஸ் இங்க அசம்பிள் ஆகுறது நமக்கு ரைட் ஆயிடும் ஆனா நம்ம கன்ஸ்ட்ரெயின்ட் என்ன ஒரு த்ரீ ஸ்பேரோஸ் ஒரு டைரக்ஷன்ல டிஸ்டன்ஸ்ல மூவ் ஆகுதுன்னா அதே டிஸ்டன்ஸ்ல இன்னொரு மூணு ஸ்பேரோ மூவ் ஆகணும் ஸோ அப்படி மூவ் ஆகும்போது இங்க இருந்து இங்க மூணு குறைஞ்சிரும் பேக் அகேன் இட் கம்ஸ் பேக் டு த சேம் பொசிஷன். So it is not possible if I have six trees and six sparrows. But whereas if I have seven sparrows and seven trees, one, two, three, four, five, six, and seven trees. Okay. So now what happens? This place to this place, two sparrows. Okay, this same way simultaneously 6 to 7, 2 sparrows. Now from here to here, from here to here, totally how many sparrows will be here? 3 sparrows. Okay, 3 sparrows. Now see here, from here to here, you will have 3. From here to here, you will have 3. See, it's moving equally. Plus 1 over here. Okay, so totally plus 1 tree over here. Totally you'll get 7 trees all assembling in this place. Here also it has traveled simultaneously. Here also it has traveled. So 3 sparrows from here and 3 sparrows from here plus 1 sparrow in that tree in the fourth place. 3 plus 1, 7 sparrows sit on the same tree. So if it is an odd number, it is possible for all the sparrows to assemble on one tree following the condition that sparrow should travel equal distance and simultaneously two direction the sparrow should travel. Constraint when these two constraints are solved only when my number is odd. But whereas when my number is even, it is not possible. This is the explanation. Coming back to your textbook over here, they say that they are giving a textbook example, some like this way, saying that a pair of sparrows flying can be modeled as an iterative step. When a sparrow I flies from left to right, it will increase by one unit. When a sparrow comes from opposite direction, the distance is decreased by minus d. This side when it's coming means the distance I explained with the number of count of the sparrows. But in your textbook, they have explained with the help of your distance. See, when this is traveling from this place to this place, it is 1 unit. So my distance increases by 1. Okay? Whereas when it comes from left to right, my distance decreases by 1. So that's why you call it any of the total distance for both of them is going to be the same. I plus a when I add, it's going to be the same. They are talking in means of distance. But I explained by the number of sparrows. Okay? Yes. Next one you have over here coming down. When you come over here, you have how they are summarizing is, okay, are able to explain the text picture. See how they are summarizing is assume 1 plus 2 plus 3 plus 4 plus 6 is equal to 21. The total number of total distance is based on the number given to the sparrow, not number of sparrows. We are calculating in your textbook. That's why I explained in the beginning with a plain explanation as a layperson understanding. Now coming back to your textbook, they are using the number for that sparrow. First sparrow, the number is 1. Second sparrow, the number is 2. Third sparrow, the number is 3. Fourth sparrow, the number is 4. Like that, they are using it. Clear? And then they are adding the number given to each sparrow. Why and all? It's an explanation for your invariant that's given in your textbook. Clear? So they are adding the numbers. They are adding the numbers given to the sparrow, not the number of sparrows. It is the number given to the sparrow. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6 is equal to 21. That is the sum of the numbers given to your sparrow. Is it clear? Yes. Which is equal to, sorry children, which is equal to 21. Okay, the number given to the sparrow is equal to total sum is equal to 21. When the loop ends, the invariant has the same value. However, when the loop ends, if all the sparrows were on the same tree, means if k means, then s is equal to 6 into k. Okay? If it is 6 means it is 6 into k. If it is 7 means it is 7 into k. Can you understand? If it is 7 means it is going to be 7 into k. Okay? 6 means 6 into k, 6 into k. Okay? And this is going to be 7 into k. Assume it is going to be in my third place means 6 into 3 is equal to 18. If it is in my fourth place means 6 into 4 is equal to 24. This doesn't match with this. That's why we say when you have 6 sparrows, it is not a 21 is not a multiple of 6. So 6 sparrows cannot assemble on one tree. Whereas when you take over here, wherever it is going to assemble, whether it's in the middle or wherever we are trying to travel and sit, wherever it's going to be a multiple of 7. 7 into 1, 7. 7 into 2, 14. 7 into 3, 21. Here, 7 into 4 is going to be equal to 28, where my sum is also equal to, what is my sum of this? 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21. What is my sum? Sum is equal to 28, which is also a multiple of 7. So in that case, it is possible for my 7 sparrows to assemble on one tree. Take the sum of the numbers given to the sparrow, which is equal to 1 plus 2 plus 3 plus 4 plus 5. If it is going to be so plus 6. If it is going to be 6 sparrows, which will be equal to 21. If it is going to be equal to 7 sparrows, means 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, which is going to be equal to 28. Okay? It is going to be equal to 28. 21 is not a that is, it is not a multiple of 6. Okay, 28 is a multiple of 6. 7 into 4 is equal to 28. So this is possible, whereas this is not possible. 6 sparrows cannot sit on one tree. 7 sparrows can sit on one tree because my sum is a multiple of 7. Here 6 sparrows cannot sit on one tree because my sum 21 is not a multiple of 6. So this is the explanation for yourself. Why this is being calculated, what it should be done, it's an explanation given in the textbook. As a lay person, practical example I explained in the earlier. But as a sum in your exercise, they have explained it like this way in your textbook. That is, at the beginning of the loop, my sum is equal to 21. Clear? My sum is equal to 21. Clear? And then at the see here, at the loop invariant, at the beginning it is equal to 21. At the end, it should be S is equal to 6 times the position. 6 into 6 sparrows, it should be 6 times the position. Clear? And then finally coming on top, here you have 6k is equal to 21. 6k is equal to 21 for our answer. Okay, loop invariant has the same value at the end as well as at the start of the loop. 21 is a multiple of 16, it's a question mark. It is not possible. Since 21 is not a multiple of 6, the desired final value of the sparrow indices is not possible with the loop invariant. Therefore, all the sparrows cannot gather on one tree. This is the answer for this question. Thank you, children. I hope so. I try to explain it. Thank you so much.